So why macromolecules? Well, we talk about macromolecules because they have a very large size compared to some of the other compounds that we talk about. And we talk about them as monomers built into polymers. So polymers are simply monomers plus monomers plus monomers, and so on and so on and so on. Okay, so we're looking for these basic units that are going to allow us to put together these very large, complex structures that will perform a function. So when we look at polymers and building these polymers, for example, all of the proteins in your body, every single one of them, are made from 20 amino acids. So we take those amino acids, which are the monomers, and we put them together in different combinations to build all of the proteins, polymers, in your body. Now there are other things as well, right? So we have 4 DNA bases. Many of you may know we have A, C, T, and G. We take those 4, that's it, and we put them together in different sequences. And so on to build very complex DNA molecules that carry all of the information in your body. Now, to build these, this is where the complexity comes in. We have to be able to put these things together. Your body makes many of these amino acids, but you also eat many amino acids. So we have to think about not only how to put these things together, but where the pieces come from. When we put them together, we're actually putting them together through something known as a dehydration reaction. So dehydration reactions take 2 monomers or more, and they put them together into a polymer. Well, if I tell you something is dehydrated, what does that mean? What does it mean to dehydrate something? You remove water, right? So when we go through the process of taking 2 monomers and putting them together into a polymer, we're actually going to use a dehydration reaction and remove the water. These are also known as condensation reactions in some textbooks. So if you see condensation reaction, it's the same thing. You're removing water. Hydrolysis reactions, hydro is what? Water. So we're actually going to use water to lyse or break a polymer. So a hydrolysis reaction takes a polymer and turns it into a monomer plus a monomer. So it's breaking things down. We will see that these reactions are typically very difficult to perform, and in most cases we're going to have to use enzymes to do this. We will talk about this in much more detail later on. Just to show you, we're taking this very short polymer with this monomer, and we want to add the 2 together. So to add the 2 together, we're actually going to remove water. So we said this was a dehydration or a condensation reaction, if you prefer condensation to remember. Okay, when we do this, we remove water and they stick together. Okay, well that's not too bad. We take a polymer, and what did we say we have to do to that polymer to get it to break apart? We're going to add water. When we add water to this, we can get this polymer to break apart, and we're back to this short chain polymer and a monomer again. Now you could continue this. You could add more water, break down this polymer into its 3 remaining monomers, and so on. We do this all day long. Every time your cells need energy, we have to do this. Every time you want to digest something and use the nutrients in that food, we have to do this. so many things are dependent on your ability to break down polymers. But in order to make enzymes, store fats, create new DNA that you're doing every single day requires our dehydration reaction from before. We have to build polymers. So you're going to see this back and forth and back and forth. So to build, in this case, a more complex carbohydrate, so glucose is sugar, we've talked about that. Glucose is our simple monomer building block for carbohydrates. So if we put two glucose molecules together, we make maltose, which is a 2-carbon ring sugar, and we also produce, in this case, some water. So is this dehydration or hydrolysis?